So certainly if you are, this is a great place to come to learn all sorts of things about PLSQL. I'll be assuming, unless otherwise mentioned, that we're working with an Oracle 10G Release 2 version of the database or higher. And you have access to all the code that I'll be running and even the PowerPoints that are reflective of the lesson I'm giving you. So all you have to do is go to www.toadworld.com/sf. That's my PL SQL Obsession website. And let's take a look. You can download, well, access lots of resources on PL SQL, but if you click on demo.zip, you can download a script, a zip file that contains thousands of scripts that I use in all of my different trainings. So all the files that I reference in the presentation as you're watching the video are files that you can access out of the demo zip and use to reproduce what I'm doing, to learn, to copy from examples, and perhaps even use some reusable code. If you click on Training, Seminars, and Presentations, you have access to all of my different trainings as PowerPoints or PDFs, including under the Fast Track PL SQL webinars, all the content that I'm talking about in this section, Programming with Collections. In addition, check out plsqlchallenge.com, which offers a daily PL SQL quiz and more with weekly, monthly, and quarterly prizes. So it's a great way to exercise and deepen your knowledge of PLSQL. And you can always visit my StephenFeuerstein.com website, mainly because you can, from there, sign up for my monthly newsletter and get information about PL SQL on a regular basis. So lots of ways to get information about PL SQL, to deepen your knowledge, to get better and better at this really great database programming language. And I'm especially excited about talking about collections with you because I believe that collections are just about the most important aspect of working with the PL SQL language. And as you can see, I'll be covering lots of topics in my lessons on collections. This is the introduction and overview. After that, I'm going to talk about defining and using collection types. You actually declare new types of data in PL SQL to work with collections. Collections have a set of methods, procedures, and functions that attach to the variable, the collection variable, and allow you to work with it. We'll talk in detail about each of the different types of collections, associative arrays, nested tables, and V-arrays. We'll look at how you can reference collections from within the SQL layer, not just in PL SQL. We'll take a very interesting look at the benefits of non-sequential indexing, essentially emulating unique indexes and primary keys right inside collections. We'll talk about using string indexes with associative arrays, a really fantastic feature that gives you tremendous flexibility. We'll take a look at how you can work with nested collections, so collections within collections. One of the most complicated features I've ever encountered in the PLSQL language. We'll talk about the multi-set operators for nested tables, allowing you to essentially do unions, intersects, and minuses on the nested table types of collections. And then we'll also talk about some best practices for working with collections. So lots and lots to talk about. Again, in this video, we'll focus only on the introduction and overview to collections. So, what, you might be asking, is a collection? Well, according to the PL SQL User's Guide, a collection is, quote, an ordered group of elements, all of the same type. In short and in general, a collection is a list of stuff, a list of strings, a list of numbers, perhaps a list of records, and much more complex structures as well. But the key thing to note is that every element in the list is of the same type, so they're homogeneous structures. And there is an order to them driven by the index. Now, collections are essentially the same as single-dimensional arrays in other programming languages. There are lots and lots of subtle differences we're going to look at in all sorts of different aspects of working with collections. But in essence, they're single-dimensional arrays. You actually can't have natively defined multi-dimensional arrays in PLSQL, though with nested collections, you can emulate them. From the standpoint of a picture, when you're working with collections, you're almost always talking about an index value, the location in the list, and the list element, like a string or a number or a date. So at index position 1, I've got apple. At index position 2, 22, orange, 100 is pear, and look at that, 10,023 is also pear. So you could have duplicate values in your collection if you wanted to. And as you will see, you don't have to have sequentially filled arrays or lists. It doesn't have to be filled in index values 1, 2, 3, 4, 5. That's a characteristic called sparseness that we'll explore in great detail with associative arrays. But at a high level, lists of information. Then you might ask yourself, well, why would I use collections? For example, relational tables are lists of information, So you don't need a collection to just keep track of a list of names or a list of records of information and so on and so forth. So yes, it's true. You could use relational tables to keep track of your lists of information, and that's in fact what we do. But collections offer an alternative to relational tables, and one of the main advantages of using collections versus relational tables is that manipulating the contents of collections is generally much, much faster than working with the contents of relational tables through the SQL language. And collections enable you to use other key features of PLSQL. So you'll certainly use collections in and of themselves just to work with different kinds of structures of data inside your programs. But most importantly, you will use collections to enable bulk collect and for all bulk processing in PL SQL, which can improve the performance of SQL-related operations in your PL SQL programs, easily by an order of magnitude, sometimes much more. You can also, and you will need to use collections with a feature called table functions. These are functions that you can select from as if they were relational tables, and essentially allowing you to hide complex transformations of data inside a function and expose it as nothing more than rows and columns. And for both of these really key features, you have to use collections, and of course there'll be many other ways that you'll apply them as well. So what makes collections so fast, you might say? Oracle has spent a lot of time and energy over the years optimizing the performance of SQL with relational tables, and absolutely, SQL operations in Oracle, whether they're from PL SQL or elsewise, are very, very fast, and of course the cost-based optimizer automates the optimization of those queries and those DML statements. So it's a very, very powerful database. But it turns out that you can read and write data in a collection much, much more quickly than in a relational table. And the reason is very simple. In general, there are two types of memory that Oracle uses to manage the data for your applications. There's system or instance level memory, called the SGA, the system global area. And then there's process or session specific memory, called the PGA, the process global area. So the SGA and the PGA. Now, I'm greatly simplifying matters, but in a rough cut, this is true. And when you work with collections, and almost really any PL SQL data structure, what you're doing is working with process global area memory, PGA memory. When you work with the contents of relational tables, you're usually working through the SQL layer in the SGA, which is a very large globalized data structure for the entire database instance. And in general, accessing PGA memory is quicker than accessing SGA memory. It's connected to your session, which means that there's less work to get to that memory, and it's less structured and easily accessible by each individual process. So per process memory is generally faster to access and manipulate than this globalized memory area. As a result, the performance improvements that you get with collections represent a very clear and a very common trade-off. You use more memory per session to improve your performance. So instead of using a shared memory area for all your different sessions connected to your database, therefore minimizing the amount of memory but increasing the overhead, the CPU time to get things done, we can essentially draw down copies of data into our different processes and then work with those process specific memory areas much more quickly, but use more memory. So in general, as you start to work with collections more and more, you've got to keep an eye on your PGA memory allocation, because the amount of memory your program uses will be multiplied by the number of simultaneously connected sessions that run your programs, that run your application. Now, the issue of memory management and the runtime memory architecture of PL SQL is covered in detail in another lesson regarding the PL SQL architecture. But quickly, let's take a look at the PL SQL memory package. Now, this is code that you can download in the demo zip that I referenced earlier, in case you haven't done this before. So just click on demo zip, and in the zip file you'll find the PL SQL memory files. Going over to Toad, let's pull up those files. So the PL SQL memory package is a package that you can use to analyze the amount of PGA memory that you've used in your program, in your current session. And essentially, to get this package to compile and use it, you have to have select authority on two $$ views. So you'll have to ask your DBA to give you authority to these views. I don't see why they wouldn't. It's a read-only access, and There's no reason that you shouldn't be able to see that information. This package, which I will not explore in any detail, is essentially a cover, an API, an interface on top of querying against the right $sign views for the right statistics. So there's not a whole lot to it, but the details are hidden away. Once you have the PL/SQL memory package defined, compiled into your package, into your schema, you can use it as follows. You can start your analysis, so PL/SQL memory.start analysis. You can run your application code, and then you can call PL/SQL memory show memory usage. I think there should be an underscore there. Let's see. Yes. Then you call the show memory usage program to display how much memory you've used. Now, what I'm doing in my very simple demonstration here is declaring a package that has within it a type of data called an associative array type. This is one of the things we'll be talking about in a future lesson, declaring types of collections. So don't worry about the syntax, but here I've got a type of collection which is a list of strings, and there's my variable. This variable is sitting inside the package level. Inside my anonymous block, I have a local variable, a list of strings, based on the package.stringsList type. And my application, quote unquote, basically populates these two different collections with 100,000 rows of data. The code here is not important at all. What matters is that I'm using collections to populate a list of strings. And if I want to know how much memory I've allocated, whoops, I left off my package name here. Sorry about that. Let's try it again. If I want to know how much memory my program is allocated and requires on a per session basis, I simply call these programs and I get this information. The change in PGA memory from the start of my program, before my program ran, and then afterwards is 8.2 megabytes. It took 8.2 megabytes to populate these two lists of 100,000 rows each. So that's a very quick introduction to the PL/SQL memory package, to the idea that you have to worry about PGA memory when you start to work with collections. Hopefully your DBA will let you install the PL/SQL memory package and you can do your analysis. If your DBA says, sorry, no, you can't have select authority on those $sign views, then you tell them, okay, I'd like to help you analyze the memory allocation in my programs, but I'll just leave it to you to sort out. And off you go, writing your code. As I mentioned earlier, there are three types of collections in the world of PLSQL, essentially three types of arrays. Oracle could have done, I think, a nicer job of organizing all these features, but this is the way it is, partly because it grew out of a historical incremental development of the feature set. We have associative arrays, we have nested tables, and we have V-arrays. And I'll talk about all of these in great detail in future lessons in this series, but essentially the associative array is a PL/SQL only data type. You use it within PL/SQL programs. It cannot be accessed from within the SQL layer. It offers the most flexibility of all the different types of collections and has been around the longest, since Oracle 7. Nested tables and V-arrays were added as part of the Oracle object model in Oracle 8 when Oracle added support for object types. And they can be used within PL/SQL blocks, but also from within the SQL layer itself. You can declare tables, define tables, that have as their type, as a column type, a nested table or a V-array. You can essentially normalize your data structures. If you want to follow an object-oriented model, this will let you do that. Again, lots more detail to come on all these topics. Glossary of terms. As you talk about collections, as you learn about collections, it'll be helpful to be familiar with the following terms. First of all, an element. A collection is made up of one or more elements, all of the same type. So again, you might have a collection of strings or a collection of dates, a collection of records. I'll also refer to this as a row. It's like a row in a table. So an element in a collection, a row in a collection, a row in a table. And they can be of almost any valid PL/SQL type. Just about any data type you're ever going to use can be used as the type of a collection. Index value is the location in the collection in which an element is found. And I'll also refer to this as the row number. So rows and row numbers, elements, and their index values. Usually, an index value is an integer, but it can also be a string when you're working with associative arrays. A really fantastic feature. Dense. When we talk about a dense collection, what I mean is that every index value from the lowest to the highest has a defined element. So if the lowest index value defined in my collection is 1 and the highest index value is 5, then a dense collection has an element defined in it at index values 1, 2, 3, 4, and 5. Now collections don't have to be dense, but often they are. And the opposite of a dense collection is a sparse collection in which one or more elements between the lowest and highest may be undefined. So for example, I can have an element defined at index value 1 in my associative array. I can have an element defined at index 5 in my associative array, but nothing in between. That would be a sparse collection. Sparse collections are trickier to work with. You can run into errors that might not occur in a dense collection, but they also offer some really nice functionality, especially to emulate unique keys and primary keys, unique indexes and primary keys in your tables. So some key lessons, some key takeaways from this introduction and overview and a look ahead. Collections are lists of data, sort of like relational tables. They share a lot of the same properties, but they use PGA memory versus SGA memory. Elements in a collection are accessed via their unique index values. Collections consume PGA memory, which is faster than SGA access, but you have a copy for each session connected to the instance, which means that if you have 100 different users connected to the Oracle database all running your program, you have to multiply by 100 the amount of memory your application needs to function properly. Next, I'll talk about defining and using collection types, the first step towards declaring collection variables and starting to work with these great data structures in your programs. So I hope this was a helpful introduction to collections, and happy PL SQL coding with collections and everything else that this great language offers to you. Greetings and welcome to the PL SQL channel, a series of video trainings on the Oracle PL SQL language. My name is Stephen Feuerstein, and I'm a PL SQL developer just like you. This lesson is part of my series on bulk processing in Oracle PL SQL. It's actually the final lesson in the series, in which I focus on converting to bulk collect. So the idea here is, how do we take code that exists in our old-fashioned format that doesn't use these great features and upgrades them to the performance levels of a bulk collect and for all process. Some quick reminders. Download the code and PowerPoint document supporting this lesson and all the other lessons from my PL SQL Obsession website, toadworld.com/sf. And make sure by the time you get to this lesson, you've covered at least the 2 key lessons before this, which is learning how to use bulk collect and learning how to use for all. So I'm assuming that you've got a working knowledge of those features, familiar with the syntax, familiar also with collections that are used to leverage these features. And then this session will make a lot more sense. So converting to bulk processing, the agenda. So we're going to take a look at the process by which you go from what I would consider to be old-fashioned code to the new approach using bulk processing features. And basically what it amounts to is going from an integrated row-by-row approach to phased processing. And we'll also take a look at what it takes to communicate from one for-all statement to another and why that's necessary. So first of all, let's start by talking about what I call the old-fashioned approach. Here's a piece of code that accepts a department ID and a new salary, gets all the employees for the department ID, iterates through them using SQL operations, using the cursor for loop, and then within that loop has multiple DML statements. In fact, let's take a look at the code itself. So again, department ID in, new salary in. Find all the employees in that department. For every employee in the department, we've got a loop body that has within it a begin end. So the idea here is that I have multiple DML operations. First, I'm going to store the current value of the salary in the employee history table. Then I need to possibly make some adjustments to that salary. So I've got my program adjust compensation that might change the salary that they're going to get. Maybe they're not eligible to get the new salary. Maybe they get even more or less. And then I'm going to update the employees table with the new salary. So 2 DML statements for each row of information that I've fetched from the employees table. In addition, I have an exception section. I trap any error that occurs for either of these 2 DML statements or the adjust compensation program. I trap any error, I log that error, and then I continue processing. So what this begin end is saying is, even if an error occurs, don't stop. Keep going through all the rows of data, get as much done as you can. And this is one of the nice features of being able to put a begin end around any block of code. I can narrow the propagation of the exception and say, keep on going. So, it's a simple program, 34 lines long. And there wouldn't be really any reason to change this unless you're working with, well,